presentation to SlideShare and YouTube tomorrow morning. All participants will be sent a follow-up email that includes a link that will allow you to download a copy. This month, we're going to take a look at the activities you will need to perform to prepare for cloud database systems, both IaaS and DBS. We're going to discuss the entire cloud migration lifecycle, from initial cloud architecture selection design to ongoing support and cost management. By default, GoToWebinar meets all participants except the speaker, which is a good thing because it reduces the chance of background noise affecting the presentation. We're going to hold questions until the end. There's a button on the GoToWebinar panel that will allow you to type your questions in. Kelly, who's the webinar's organizer, will bundle them up. We'll discuss them at the end. We want to be respectful of your time. We know that many of you will have meetings right after this one. I've timed the presentation to allow a Q&A at the end, but if we're in danger of running over, I'll respond to many questions by email. For our December webinar, Jeremy B.I. Fry, RDX's Microsoft Business Intelligence Team lead, will be demoing Power BI's new features. I also distribute a monthly newsletter that you might be interested in. It covers a wide array of tech topics that we think would benefit readers both personally and professionally. You don't have to be a customer to receive it. If you'd like to be added to the distribution list, let me know. I'll display my email on the last slide of this presentation. You can also add me as your LinkedIn buddy. I write articles and SlideShare presentations on a lot of different wide-ranging tech topics. So let's get started with today's presentation. I'd like to introduce who RDX is, and I'm not showing this slide as a cheap advertisement for our services. What I'm attempting to show is that RDX has experience monitoring and administering a wide range of environments. We support thousands of databases and operating systems. This includes cloud IaaS, DBS, on-premises, relational, NoSQL, commercial, and open source database products. One of the benefits that RDX can provide to all shops is a wide range of expertise. It's just the nature of our business. We support over 800 customers, so we're not constrained by any one shop's tech stack. We are required to administer virtually every database feature you can think of for every product we support, and we work with dozens and dozens of different tech stack combinations. RDX focuses on data infrastructure support services for databases, operating systems, and edge technologies. Because of the increasing interest in cloud services, especially migration, we separate cloud support from our on-premises services. We offer two different types of support contracts. Full outsourcing support means RDX assumes total ownership of the customer's environment. We also offer supplemental support contracts. We augment the customer support teams. We can provide daily administration, or the client can use our services to fill critical support gaps for leading-edge technologies and product features, or a combination of both. We support most IaaS offerings, which we're going to learn is just a server in the cloud. We also support Azure DBAS DBs, Amazon RDS, and Oracle's Cloud DB platform. The cloud platforms that are garnering the most interest from our customers are from Microsoft and Amazon. Because of our large customer base and number of supported servers, we're a good bellwether for the adoption rate of different technologies and support strategies. Here's what we've learned over the last few years supporting cloud database management systems. They are increasing in popularity. As they do, the requests for our services are also increasing. Cloud environments are architectures. They're not products. Depending on the vendor you choose, the complexity of these architectures and the way you administer them can range from very simple IaaS platforms to extremely complex multi-cloud DBS environments. Not only are Cloud DB architectures different from on-premises systems, depending on what offerings you're comparing, they can be dramatically different from each other. From provisioning or building the system to administration of mature systems, the changes can be extensive. We'll be doing a deep dive into some of these challenges in upcoming slides. The intent of this presentation is to discuss how these architectures will change the way you provide support. We'll also learn that some databases are more cloud-friendly than others. There's lots of cloud options to choose from. Here's a couple of quick database as a service, DBAS examples. There are also dozens of IaaS providers to choose from. We're going to talk about DBS versus IaaS in a couple of slides. DBS and IaaS are different architectures, and we'll learn that a DBAS architecture will have a much more significant impact on your IT support procedures and documentation. Choosing the right architecture, cloud vendor, and database product will be a critical part of your initial strategy. The market landscape no longer consists of a handful of traditional on-premises relational database offerings. The market's exploded with dozens of new alternatives from organizations that range the spectrum in price points, architectures, storage models, and feature sets. The seemingly endless array of alternatives can easily become bewildering. The challenge with the cloud is that the offerings provide different computing architectures. We'll be focusing on these differences in upcoming slides. Amazon, Microsoft, Google, Oracle, Rackspace all offer cloud platforms, and they are all totally different architectures. How they calculate rental costs, interfaces, features, how you administer and monitor them, tuning, security, backup recovery, high availability. Once you select a cloud architecture and a vendor, you must fully understand the new environment before you begin using it. I have a lot of upcoming slides that provide information on the key areas you need to focus on. The amount of impact I'm describing is entirely dependent upon the cloud architecture and database product you've selected. Let me provide you with a quick example. Amazon RDS, Amazon Aurora, Google SQL, and Oracle all offer DBS versions of MySQL. When we dig deeper into the vendor's platforms, we find that not only are their architectures different, but their implementations of the MySQL database product, they're also different. You can't expect to get the exact same feature set of MySQL DB product features on Amazon RDS MySQL as you would with Oracle Cloud MySQL. Oracle's totally customized MySQL for the cloud. As a result, Oracle's MySQL Cloud platform provides a lot more cloudy features than its Amazon counterpart. The same issue occurs with most of the MySQL vendors' DBAS offerings. This isn't just a MySQL issue. You'll find that other DBAS products, SQL Server, Oracle, PostgreSQL, will often differ based on the cloud vendor. RDX's recommendation is to thoroughly evaluate both architectures and database products, especially features, when you're comparing the vendors. Depending on your overall cloud goals and size of your organization, you will need to consider the creation of new strategies and standards. I've included a laundry list of both on this slide. Since the cloud is a new architecture, it will affect all areas of IT and also impact how technology supports business ops. The strategies and standards that are impacted will range the spectrum, from your change management policies and naming conventions to high-level organizational strategies. These aren't all simple decisions, and they will ultimately determine the success of your overall cloud strategy. Cloud strategies will have very high visibility with executive management in any shop. The amount of documentation changes required will depend upon the breadth and depth of documentation your particular shop requires. Larger shops traditionally have more documentation and procedures in place than smaller organizations. In addition, organizations that are governed by internal, industry, or governmental regulatory requirements are required to have more documentation and standardized administrative procedures. According to two industry-leading advisory firms, the top two reasons that shops are concerned about moving to the cloud is security and loss of control over their environment. Most managers feel secure knowing that their shop is in total control of the environments they are tasked with supporting. When you move to the cloud, you're going to share that responsibility with a third-party vendor. That loss of ownership is a big sticking point for many organizations, which is perfectly understandable. And this will impact your organization, especially when problems occur. You'll need to go to management and explain to them that their favorite IT department, meaning you and everyone you work with, is no longer totally in control of the availability, performance, and recoverability of their critical computing environments. Some shops may view this as a benefit, others will view it as a risk, and most will view it as a combination of risk and reward. We all have experience with on-premises systems. We have to build the server rooms, provide heating, cooling, redundant connectivity, and power. We are then required to buy the server hardware, install, and maintain it. In addition, we evaluate, buy, install, and support all the other products we need. Databases, application tiers, middle tiers, monitoring, security, auditing, third-party reporting products. We have to buy and support everything, both the hardware and the software. The cloud architecture that is the closest to on-premises is infrastructure as a service. With infrastructure as a service, the vendor provides the compute and storage infrastructure components and may offer some level of system maintenance activities. You have direct access to the server and storage, much like on-premises systems, but you're able to leverage a higher level of elasticity. Think of it as a server, more often than not, a virtual server in the cloud. You don't have to build your server support environment that provides air conditioning, light, multiple power providers, UPS systems, generators, and redundant connections to the internet. All that's provided by the vendor, but you will continue to maintain ownership of your software stack's administration, including the operating system and database. You install and administer your software of choice on that platform. Now that we know that IaaS is pretty much just a server in the cloud, let's move on to DBAS, Database as a Service. DBS vendors provide all the server environmental benefits that their IaaS counterparts do. But DBS significantly raises provider control over the customer's environment. DBS providers assume ownership of the operating system and the database software, as well as the hardware. DBS customers perform little to no operating system and DB software administration. The vendors will be constantly enhancing their architecture's automation capabilities to further reduce the human labor required to administer their environments. IaaS allows you to maintain tighter administrative control over your environment. You can more easily leverage your favorite internal third-party products on IaaS systems than you can with DBS. Many of the third-party tools, monitoring security, application development, auditing, can be challenging to integrate into a DBS architecture because of the modifications the vendors make to their systems. All the DBS vendors provide monitoring tools. Some vendors like Amazon charge you extra if you want a more robust monitoring solution than what is offered by their base package. DBS offerings allow you to more easily configure complex architectures, high availability, disaster recovery. All the major DBS providers offer geo data redundancy. You also need to remember that since you're renting the DB and OS software, when that relationship is over, you don't own anything. Let's spend a few minutes on the creation of an IaaS versus DBS cloud architecture strategy. What's your experience level? If your shop is just starting out, you may want to test the waters using infrastructure as a service and then move into database as a service once you gain experience. IaaS is much closer to on-premises in terms of support and product compatibility. If you prefer to rent your OS and DB software, DBS is going to be the better choice. We'll learn in today's webinar that not all the features that are available in on-premises databases are provided by their DBS counterparts, and that's a big deal. How many changes are you comfortable making to your application software and database? How about your internal procedures, processes, change management, security? You will need to allocate human capital, create project plans, and allocate funding to their modifications. The impact of those changes will be much higher on DBS than if you chose IaaS. What benefits are you expecting to receive from the cloud? Save money, improve flexibility and scalability, faster application time to market. Maybe you want to more easily leverage highly available disaster recovery architectures. The reasons why you want to go to the cloud will drive your IaaS versus DBS decision. You'll need to investigate your shop's software products that interact with your database systems. If you're going to use DBS, you will need to verify that they will continue to work or find viable replacements. You will also need to evaluate DBS on-premises feature mismatch. We're going to discuss that in a couple of slides. Are your systems heavily audited? IaaS provides greater visibility and ease of access to the system than DBS. We just learned that IaaS is a server in the cloud. Like everything else in the cloud, you do have options. In addition to choosing a cloud provider, you can also choose from single and multi-tenant IaaS platforms. You traditionally see more information on single versus multi-tenant environments for software as a service. You can choose to share an application environment with other tenants or rent an application environment that is dedicated to your organization. But you also have the same option with IaaS. You can share a computing environment with others or have dedicated computing resources. Oracle has a very strong single-tenant offering called Cloud Compute Classic. You pretty much get a dedicated computing hardware platform. In June of this year, Google announced sole tenant nodes, and both Microsoft and Amazon will provide customers with dedicated environments. There's a lot of variations between vendors for the term dedicated. You will need to read the vendor's definition for dedicated to determine exactly what that term means. Now that you've chosen an architecture, what vendor are you going to choose? To show why vendor selection is so critical, let's take a look at two of the industry-leading offerings for SQL Server DBaaS, Microsoft and Amazon. Let's highlight their differences. Although Azure SQL DB is Microsoft's flagship relational database as a service offering, the vendor does provide a wide range of cloud-based DB systems. Microsoft describes Cosmos DB, and it's one of my personal favorites, as a globally distributed multi-model database. We're all aware that in the past, Microsoft has been pretty reserved when it comes to offering products to consumers that it didn't create. That mindset has certainly changed, as we know that SQL Server is now able to run on Linux, and Microsoft offers fully managed cloud services for both MySQL and PostgreSQL. Microsoft SQL Data Warehouse is a fully managed petabyte-scale cloud offering. There's a lot of different DB products to choose from. Amazon also offers a broad and deep suite of cloud DBMS services. Customers can choose from Amazon's fully managed database product offerings that include Relational, Aurora, NoSQL, DynamoDB, Data Warehouse, Redshift, and in-memory, Elasticache. Amazon's RDX product suite provides consumers with 5 managed database engines that include SQL Server, Oracle, MariaDB, MySQL, PostgreSQL. We need to understand that DBS cloud offerings don't provide the exact same features as their on-premises counterparts. Let's take a look at the feature mismatch for both Amazon RDS and Azure SQL DB for SQL Server. It's important to remember that you must evaluate the on-premises DBS feature mismatch for any DB product that you're migrating to the cloud: Oracle, MySQL, PostgreSQL. Let's begin by evaluating the feature differences between Amazon RDS for SQL Server and SQL Server on-premises. The features listed on this page do not exist in Amazon. If you currently use SQL Server on-premises, you'll need to be aware of these differences before you begin migrating databases to the cloud or creating new DB systems in Amazon. You'll find a list of features supported and not supported in Amazon's product-specific documentation. Some of these feature mismatches are complex, and it can be a challenge to leverage the like functionality provided by Amazon. DBAs and developers are often required to work together to come up with a viable solution. Here are the feature differences between Azure SQL DB DBAS and SQL Server on-premises, 2 versions of SQL Server offered by the manufacturer. You'll need to identify the features that aren't available in the cloud, distribute them to your third-party application vendors and internal developers to find out if their applications will work with that DBAS system. If they rely heavily on a particular feature to provide critical application functionality that isn't provided by the DBS platform, that database or databases will need to be modified, or they could be moved to an IaaS architecture. Amazon has been offering administrative certifications for some time now. Oracle certifications now include Cloud Service Operation, Cloud Administrator Associate, and Cloud Professional. Microsoft OS certifications now differentiate between public and private cloud implementations. As your cloud footprint grows, you will need to evaluate how your IT shop is organized. Do you want your administrators to support both on-premises and cloud platforms, or do you want to assign those responsibilities to different team members? Do you want to create new teams that are responsible for administering cloud systems, or keep your current org chart as is? Security. That's the #1 concern when shops are considering cloud implementations. We're all aware that we need to tightly secure the database. Not only do you need to secure and audit the databases themselves, some shops seem to forget about all the other objects that need secured and audited. How about input and output files, database load files, report files, work files? Your shop will be transferring data to and from the cloud system. These files will now be stored even temporarily off-premises, and your security teams will need to put the appropriate policies and procedures in place to protect and audit their usage. In addition, you will be using a cloud architecture, an architecture that will be secured differently than on-premises, as well as other cloud environments. Your security team may be using different commands, tools, and interfaces. Evaluating initial and ongoing costs is critical. As we learned previously, you aren't purchasing your environment, you're going to be renting it. I'm going to be saying that term a lot. You can search the web and find numerous cases of shops that didn't do their due diligence when they configured their cloud system and were surprised, how about shocked, at the charges they were incurring. This isn't the vendor's fault. It's the customer's responsibility to fully understand each vendor's costing calculations. We're going to evaluate Amazon SQL Server for RDS and Azure SQL DB's costing models in our next set of slides, just to show you how different they are. All cloud vendors provide some type of cost calculator that you can use to estimate your monthly charges before you begin provisioning your instance. Here's Amazon's. If you have one takeaway from this presentation, it should be to use the cost calculators to perform what-if scenarios. Select on-demand and reserve payment options, different regions, instance classes, and disk allocations. Choose different disk configurations. Configure a HA architecture. Read the information provided by the help pop-up bubbles. Every time you make a change, the cost calculator will show you an estimate of what your monthly cost will be. This what-if testing will help you to customize your cloud environments to meet your needs and your budget. Let's take a look at some of the factors used to generate Amazon RDS instances rental costs. This is going to explain why it's so important to have a firm understanding of each vendor's costing models. So for Amazon, you can pay on demand, reserve an instance for a 1 year or 3 year term. You will incur the highest rental fees if you choose on demand. The longer the term you choose and the more money you pay up front, the lower your instance's hourly cost will be. You can also choose to include a license in your rental fee or bring your own. Database additions, they're also going to impact your hourly costs. It's obvious you'll pay more for SQL Server Enterprise than you would for Express Edition. You then need to size your instance, how much memory, CPU, and network performance you want to reserve. The configuration for this example I use on this slide is for a db.m4.10x large instance. The letter M indicates that this is a standard class instance, not memory optimized. Amazon recommends configuring RDS databases to use memory optimized. That's the R option. The number 4 indicates that this is the current gen instance. The higher the number, the later the generation. 10x large would be 10 virtual CPUs. The EC rating to compare against other selections would be 124.5. You can use this instance in a virtual private cloud for security. The instance can be configured to use EBS. The maximum bandwidth is 4,000 megabits per second, and the network performance rating to compare against your other selections is high. Amazon offers a lot of instance performance configurations to choose from. The vendor provides a table containing detailed descriptions for all instance performance configurations. It's a pretty simple process to scan that table to select the performance configuration that best meets your needs. You also need to evaluate data transfer charges. Amazon provides details on data transfers at the bottom of every RDS DB's products pricing page. Some of the data transfers are free and some aren't. Most vendors will charge you for data transfers into and out of the cloud and between regions. If you're going to be transferring a lot of data, you'll need to factor these costs into your estimation. Let's take a look at the Microsoft cost calculation panel. Microsoft offers vCore and DTU costing models. The DTU model is based on a bundled set of compute, storage, and I/O resources. Performance levels are expressed in terms of database transaction units, DTUs, for single databases, and elastic database transaction units, eDTUs, for elastic pools. The key factor is that it combines compute, storage, and I/O together. It's pretty complex. The vCore model simplifies costing by allowing you to independently choose compute and storage resources. I'm selecting an elastic pool of databases. My choices are single database or elastic pool. With a single database, you estimate the amount of resources that a database requires to handle its workload. SQL database elastic pools allow you to combine multiple databases and their workloads into a group, and then allocate shared resources to the group. You assign DBs that have workloads that spike at different times to reduce your overall resource usage rental costs. You can see the performance level dropdown that shows all the DTU and storage size combinations we can choose from. We select our combination of CPU, memory, and I/O DTUs, and the default storage that comes with it. You're also able to add additional disk storage. I provide some of the options in the list on this slide, but they're pretty simple to configure. After you migrate, one of your top priorities, in addition to making sure everything is working fine, is to monitor resource consumption. If you don't, you may end up with a budgetary surprise or two. The vendor, architecture, and tier you select, as well as how you configure them, will impact your monthly fees. Of course, our recommendation is to do the background work to understand them, choose the settings that are best fit for the environment you want to build. Then monitor your fees regularly and adjust as necessary. We all know that it can only take a few improperly tuned queries added to the system to impact the resource utilization of any environment, on-premises or the cloud. The challenge with cloud environments is that any spikes in your workloads, it's going to impact resource utilization and possibly the performance levels in tiers you chose during your initial configuration. Remember, once again, you're renting the cloud environment and you're going to be charged by the vendor based on resource consumption. Because the environment is different than on-premises systems, you'll have to update your change management processes and documentation. How long that takes, the number of texts you'll have to dedicate to the project depends on, once again, the architecture you choose and how stringent your change management processes and documentation requirements are. Because DBS is administered much more differently than on-premises, it will have a greater impact than IaaS, which we learned is just a server in the cloud. Here's an example of Amazon's admin panels. Top left is the Oracle Database configuration screen. Top right is the design panel for high availability. In this case, it's a primary Oracle database with a secondary standby environment that uses Oracle Log Shipping as the transfer mechanism. Amazon also provides a graphic configuration utility with templates to build entire applications. The utility is called Amazon Cloud Formation. They allow you to choose between YAML and JSON as the language to configure the options. You use the graphic designer to build the environments, and you can view the code at the bottom. You'll need to identify all the build, administration, monitoring, and access tools that your shop uses to interact with your on-premises databases. All shops usually have a couple of must-have products that are frequently used. We learned previously that IaaS architectures server in the cloud, so we shouldn't have a big problem getting our preferred on-premises tools to work. But it's not so easy with DBAS. The popularity of the cloud is driving most software vendors to make sure their offerings work with cloud systems. But you will need to double check. Our recommendation is to create a list and verify that those tools will continue to work with the cloud versions of the database. You also need to learn the cloud vendor's admin tools. Let's take a look at Amazon's tool sets for an example. The AWS Management Console provides visibility into your entire Amazon environment at a global level. The Management Console provides links to the individual specific service consoles, which includes Amazon RDX for your databases and CloudWatch for monitoring. Think of it as a jumping off point that allows you to drill down into the specific services you're using. The Amazon RDX console will be the primary interface you use to administer your database environments. In addition to the administrative panels you will use to create, configure, and administer your DB systems, the RDX console allows you to configure monitoring. Amazon provides a couple of different mechanisms you can use to monitor the health of your database instances. Amazon CloudWatch provides panels that allow you to review current alarms and statuses. You can review alarm and resource utilization graphs and overall service health statuses. In addition to the administrative panels, the vendors also provide their own unique performance monitoring tools. Let's use Microsoft Azure SQL DB for this example. Microsoft provides a monitoring portal that allows you to drill down into a vast array of resources and metrics. Here's a screenshot of Azure SQL DB's Query Performance Insight utility that allows you to drill down into specific queries. It provides a traditional highest resource consuming queries first display. You're then able to review the history of the query's resource utilization. If your DBAs are familiar with tuning on-premises databases, they will be able to apply most of that knowledge to cloud databases. But they will also need to fully understand the new cloud architecture, learn the cloud-specific tuning knobs, and become proficient with the vendor's cloud monitoring displays and advisors. Let's talk about these advisors. Many cloud vendors provide advisors that scan your environments, apply a set of best practices, and generate recommendations. RDX highly recommends that you leverage the advisors throughout the cloud deployment, development, and mature system lifecycle. One of the biggest challenges shops will face with their cloud environments is that the costs will exceed what they budgeted. The critical factor, you're renting the environment. You have to constantly monitor resource utilization. Let's use Amazon and Microsoft again to highlight some of the architectural differences between the different cloud platforms. Amazon currently has an enormous lead over both Microsoft and Oracle cloud customers and cloud revenue. In addition, since it has a head start on its competitors, it has built a very robust cloud service architecture. I've created a list of features that customers are able to leverage when they deploy databases on Amazon's architecture. On our next slide, we'll learn why Microsoft's Azure SQL DB platform is so different than Amazon's RDS for SQL Server environment. This is really important. The big difference between Amazon and Microsoft's cloud versions of SQL Server is that Amazon takes Microsoft's on-premises database software and modifies it to work in their environment. The database isn't modified as heavily as Microsoft's DBAS offering. Most of the cloud features and benefits you can take advantage of are inherent to Amazon's underlying cloud architecture, not specific database modifications. Microsoft has built an entirely new database product that is architected from the ground up to run in its cloud environment. As a result, you'll see a lot of cloud-specific features that are available in Azure SQL DB that Amazon does not provide. Let's learn more about Amazon's architecture. We'll see why it's different than Microsoft's. The Amazon cloud consists of 18 worldwide geographic regions. Regions are then broken down into availability zones. An availability zone is a data center that has all the environmental resources required to ensure it's highly available. The data centers are in different geographic locations with enough distance between them to ensure both data centers aren't affected by most, that's the key word, unfortunate events. Traditionally, customers choose regions that are in close proximity to their user population. You'll need to verify that all the products you want to use are available in the region you're selecting. Amazon RDS, that's the database product suite, is available in all regions. But if you're going to use other Amazon products and you want to keep everything in the same region, you want to make sure the region provides support for all of your selected products. DB instances are configured to run in a region's availability zone. When you configure a multi-AZ environment to provide HA, you're creating a primary instance in one availability zone and a standby instance in a second availability zone. Using multi-AZ implementations isn't a requirement, but it is highly recommended. It's a pretty simple process to select the multi-AZ option during configuration. When you configure HA in Amazon for SQL Server, all databases in the instance will be mirrored. You can't replicate across regions. You only have one standby mirror, and it can't be used for read access. Let's take a quick look at Microsoft's cloud infrastructure. Same term, region. A region is location for a Microsoft data center. Multiple regions provide the benefits of allowing you to put data closer to your users. Although Microsoft and Amazon both have regions, Microsoft does not have the concept of availability zones. Of course, the other benefit is it allows you to take advantage of geo-replication for DR. Like Amazon, not all of Microsoft's cloud offerings are available in every region. You can find a list of what products are supported for a given region using the link at the bottom of the slide. Azure SQL DB provides a robust set of HA options. Much more than Amazon RDS for SQL Server. We just learned about the two pricing options, the DTUs and vCores. If you choose DTU pricing, you can choose from basic, standard, and premium service tiers. If you choose the vCore option, you can choose from general purpose and business critical service tiers. For DTU Premium and vCore Business Critical tiers, that's the high options, Microsoft uses a 4-node, always-on availability groups cluster to provide HA. Wow, that's a pretty robust environment. Amazon uses mirroring, not always-on availability groups. As you can see in the right column, Microsoft provides more HA options, more secondaries than Amazon. They can be in different regions. They can be readable. Microsoft also provides Azure SQL DB failover groups that provide automatic failover capabilities. Your staff will need to be trained to learn the new architectures. You will have to commit resources and then provide them with the time required to learn the new architecture. Provisioning, administering, tuning, securing, monitoring, backup recovery, disaster recovery. It's the same basic principles of good database administration that apply to all DBS environments. But depending on the environment you choose, your administrators may be using different tools, utilities, and commands to perform their support operations. We now need to select databases to be migrated to the cloud. Some databases are more cloud-friendly or work better in the cloud than others. One of the challenges that we need to evaluate is exactly how much data do you need to transfer back and forth to that architecture? How much data and how long is it going to take to send and receive it? In addition, we'll need to determine if our vendor charges us for those transfers and how much. Does the database interact with other systems? A popular feature in any DBMS is using its inherent linking capability to access data in other systems. You can use a single SQL statement to access one database and then use links to join that information to data residing in other databases. Will those other databases be on-premises or will they be in the cloud? Does it generate a lot of output? Do you use that database data to refresh other systems? Does it generate large reports or flat files and other data streams that are used as input to other applications? What features does the database use? We will need to verify that all the features utilized in that database are available if we choose DBAS. If you use a particular feature that's not available or the cloud service provides like functionality, you will need to determine how big of an impact that's going to be. We will also need to analyze all the software that interacts with the database. Application software, utilities, monitoring, security. Not a big deal if we use IAS, but it is a big deal if we choose DBAS. Does the database utilize any highly available features? How critical is it? What are its backup requirements? How many copies of your backups do you need to retain? You can be charged for them. How big is it? How will you initially seed the database? Some of the vendors will send you a disk storage suitcase. You copy your database onto that device and send it back to them. That way you don't have to send your entire database over the internet for its initial seeding. Security. Is the database governed by internal, industry-specific, or governmental regulations? We learned that DBAS environments don't have the same level of visibility as IaaS or on-premises. You will also need to estimate the processing workloads, renting the environment again. And it'll be based on CPU, memory, I/O, disk storage. Are your workloads fairly predictable, or do they have large fluctuations? If they fluctuate heavily, Microsoft's Azure SQLDB Elastic pools, that's an excellent alternative. The more databases you can add to a pool, the greater your savings become. The fewer databases that peak at the same time, the lower the pool resources can be set and the more cost-effective the pool becomes. We need to estimate how much work it's going to be to migrate that database to the cloud. Your options can range from lift and shift with minimal changes to a total application rewrite. You may have outdated apps you want to rewrite from scratch. What we need to remember is that no database is an island. As I said, they take feeds from flat files and other database applications and produce output that is ingested by other apps and end users. Getting a lot of data into and out of the cloud can be challenging, especially if there are tight time constraints and large data volumes need to be transferred. We also need to evaluate application performance. Application placement is critical, especially for online transaction processing OLTP apps that require fast data access. If your application is on premises and your DB's in the cloud, your database calls, they're going to have to traverse the web to interact with the database. That will increase response times. If your application resides on the same cloud platform as the database, data access will be faster. How big are your internet pipes? Can they handle the additional workload? What are the application's performance requirements? What kind of app is it? If it's a decision support system, adding a little bit of time onto queries that run for minutes or hours won't have as big of an impact as it would with a transaction processing application that measures response times in seconds, sub-seconds, and milliseconds. All these questions will need to be evaluated. All the leading cloud database providers want to make it absolutely as easy as possible to migrate your on-premises databases to their architectures. They all offer strategies and mechanisms you can use to initially seed the cloud database with your on-premises data and then keep the systems in sync until you're ready to perform the production cutover. The mechanisms you choose to migrate the system will depend on several key factors: the target platform and product. Will you be switching database products during your cloud migration? The transfer, conversion, and sync tools provided by the cloud vendor. How much data are you going to be migrating? And the acceptable outage length. Can the system be down? If so, how long? Let's take a look at Microsoft and Amazon's migration utilities. Every cloud vendor will have different migration utilities, and your shop will need to understand them. In Q4 2016, Amazon released the AWS Database Migration Service, DMS. It's a very robust replication utility that allows you to initially seed your Amazon cloud database with data and then keep it in sync with your on-premises system. The replication utility allows you to migrate larger systems to Amazon and also provides shops with the ability to maintain cloud on-premises hybrid architectures. This is important. Not only does the product provide replication between homogeneous sources and targets, Oracle on-premises to Amazon Oracle IS, for example, it also allows you to set up replication between heterogeneous platforms, Oracle to Aurora, SQL Server to MySQL. Amazon also provides the AWS Schema Conversion Tool. Amazon states that SCT can automatically convert the source database schema, including views, stored procedures, and functions, to its Amazon counterpart. The product also allows you to scan application source code for embedded SQL statements and converts them to access the new database product. Let's take a quick look at some of Microsoft's cloud migration utilities. It's important to note that Microsoft's migration and replication utilities aren't as robust as Amazon's in terms of database conversions. Amazon provides a wide range of product conversion options. Migration is getting your database into the cloud, and conversion is changing databases along the way. The Data Migration System, or DMA, scans the on-premises database and detects compatibility issues that may impact the functionality of your Azure SQL database. Amazon does not provide that kind of utility. DMA will identify compatibility issues that may prevent successful migrations from SQL Server on-premises to Azure SQL DB. We learned previously that although the Cloud DB system may not have exact same features as its on-premises counterpart, it has features that provide similar functionality. DMA detects partially or unsupported features that are currently used in your source SQL Server database. It then provides a set of recommendations or alternative approaches available in Azure and the steps that can be performed to implement them. But you will be required to implement those procedures. It doesn't automate that part of the process. When you're ready to perform the migration, the Azure Database Migration Service, DMS, automates the conversion activities. The big benefit of DMS is that it allows you to set up replication to keep your on-premises and Azure SQL DB environments in sync until you perform the final cutover. Now that we've selected our database or database migration, let's take a look at the higher-level steps we're going to perform. Planning for a cloud migration is like any other tech project that's complex and has a lot of steps. You'll need to dedicate time to educate your team in the cloud target you've chosen. You'll want to be familiar with how the data is stored, how your applications will connect to the cloud database, how it will be administered, monitored, secured, audited, and backed up. Does your team know how to recover the system? Will you be implementing HA architectures? Are there any feature mismatches that you will need to plan for? How will you transfer data back and forth to the cloud during daily database operations? Can your network and cloud connection handle that increased volume? You also need to determine if you want to migrate the database to the cloud in one step or you want to seed it, but keep it in sync until you're ready to flip the switch on your final production cutover. Some of these steps I'm showing may be combined or removed entirely. Depending on the mechanism you choose, you can migrate the database structure and the database at the same time. You may choose to migrate the database data and cutover after you verify it has been successfully moved to the cloud without setting up synchronization. Here's a key step. What steps are you going to perform to verify that the database has been successfully migrated to the cloud target? As I stated when I started discussing this slide, cloud migrations are much like any other tech project. Robust testing and verification will be critical components of your test plan. Depending on the vendor, architecture, configuration, and DB product chosen, you may find, not may find, you will find that you'll be tailoring your database configuration, tools, utilities, interfaces, SQL statements, procedural language. The list goes on and on to work in that vendor's environment. The more you need to tailor your tech stack configuration to any vendor, the more locked in you become. There is a greater amount of vendor lock-in for DBS than any other platform you can choose. During your initial evaluation, you will need to determine how much customization you will need to perform by performing the proper due diligence, and also determining how important it is to your organization to have the freedom to swap vendors. A recent poll of 1,200 global business and IT decision makers found that 60% of the respondents felt that resolving cloud service interruptions was the primary responsibility of their cloud service provider. 83% stated that their provider was responsible for ensuring workloads and data in the cloud are protected against outages. Okay, that's great. So we're all going to rely upon the cloud vendor for availability. But what about the impact to your organization during the time you are relying upon that vendor to get their environment back up and running? Do you have any fallback plans in place? Do you have a documented course of action when an outage occurs? Here are RDX's recommendation for those customers considering or implementing cloud-based DBMS solutions. Your strategy could be, we want to test the waters. That's what we recommend. Try the cloud on a few selected apps, but you need to choose the right ones. Thoroughly understand the architectures and select the vendor offering that best meets your needs. Then realize that they're going to be supported differently than their on-premises counterparts. This isn't an architecture that should be entered into without much analysis and forethought. We're here to help you when you're ready. RDX doesn't profess to be an expert in all things cloud. The benefit we provide is we have a large customer base and many of our clients use cloud database systems. We are, above all, a learning organization, and our collective egos don't prevent us from saying that we teach, but we also learn from our customers. This wraps up today's presentation. Just a quick note, mark your calendars for RDX's next Insight Series webinar. On Thursday, December 6th, RDX's Microsoft Business Intelligence Team Manager, Jeremy B.I. Fry, will be providing us with a Power BI overview and demo the tool's features. Jeremy is presenting at this year's SQL Pass user conference. He's an expert at all things BI, so this is a presentation you don't want to miss. His demos are both informative and very entertaining. You can always send me an email to receive our newsletter. You don't have to be a customer to receive it. My email's on the upper right-hand corner of this slide. So Kelly, do we have any questions for today?
Yes, we do have some. I'll begin with this one. What is the single greatest mistake shops make when migrating applications to the cloud?
Well, there's actually a few that are the most popular that RDX has come across. First was not having a well-thought-out strategy. How are you going to use the cloud? Do you know the steps you're going to take to migrate applications in your databases? And how are you going to administer them once they're up there? You have to plan for these things. All phases of the cloud migration lifecycle need to be analyzed, and you need to create strategies. Another one is underestimating the amount of interaction the selected DB-driven application has with other systems. We talked about that common DBA developer practice, how they use those internal DB links to allow a single SQL statement to access data from another database from within the source. Where is that database residing? Is it in the cloud? Or the volume of data being transferred into and out of the cloud environment is higher than expected. I show the slide stating that no database is an island. There are very few environments that are actually standalone. This includes data being ingested by the cloud database and the data it generates and sends to other systems. Here's another big one, not evaluating the features utilized by the database being migrated. You have to identify all the features the database uses before you even begin considering the cloud migration. There's a lot of horror stories about shops getting caught because they missed some features that weren't available. Lastly, you need to understand, I kept saying this throughout the entire presentation, renting. You're renting the architecture, and it's going to be based on resource consumption. They often underestimate the amount of resources the database will consume. Then they get sticker shock when that first monthly charge comes in. Any more questions?
Yes. How many clients have you noticed have a desire to be cloud agnostic or have a preference to IaaS to DBaaS?
You know, right now, the way we're with our customers, we're seeing the majority of them use IaaS. And we've sent surveys out, and based on those surveys, it seems like they're testing the waters with IaaS, and that's the most popular architecture. But we are seeing an increasing growth in DBaaS platforms. And in that survey, we asked them what were some of the prohibitive factors that were, preventing you from going to a DBaaS platform. And a pretty high percentage of that result came back saying that there were too many changes that needed to be made to their organization, to their technology platforms, to the databases themselves. That was preventing that migration to DBaaS. Not many changes you need to make to IaaS. We learned in this presentation it's served in the cloud. Any other questions?
Yes. What recommendation would you make to shops considering cloud architectures?
Probably leverage the skills of techs that have been there and done that. Hire some consultants that have a well-documented background in cloud architectures to provide you with advice. How about going with a service provider? I'm not trying to sell RDX as a service. Go with us or go with a competitor. We're going to help you migrate to the cloud, and we're going to support it for you once you're up there. Well, because our models are based on ongoing support, we're going to make sure you choose the correct architecture and platform, in addition to the proper steps to migrating. We're going to support it after it's migrated. It's in everyone's best interest that we want to work with you to create a well-thought-out strategy and migration plan. This isn't a sales pitch, just my advice. Don't go it alone. Look at consulting companies. Don't go it alone, as mistakes are costly, and cloud migrations have high visibility with any executive management team, mainly because of the hot architecture right now. You blow that, you're in big trouble. Any other questions?
Yes. What is the future for cloud architectures?
Whoa. Right now, I feel that the most beneficial in the near term is going to be hybrid. We're going to have on-premises and cloud architectures for some time. We hear a lot from the industry pundits saying that the cloud's going to kill on-premises. It was just like open source systems, and we're going to kill the mainframe 20 years ago. It took a long time to migrate from the mainframe to the open platforms. Everything isn't going to be migrated to the cloud at a wholesale level. We are going to be administering both on-premises and cloud architectures for some time. Administering the same way is key. Seamlessly transferring databases from one cloud architecture to another, or between on-premises and cloud, that's going to be a critical feature. I think we'll see further advancements in containers or container-like constructs, which is going to allow us to easily pick up the environment and move it from one architecture to another. My top concern for the future is vendor lock-in. It's much harder to extricate yourself from an architecture than it is a DB product. Migrating from one database to a different one, that's pretty challenging. Migrating between different compute, storage, app, and DB architectures is much more challenging. Everything changes. Any other questions, Kelly?
That's all of them.
Okay, I'd like to thank everybody for attending today's webinar, and we'll be sending invites for our December webinar on the Power BI demo. Thank you, everybody, and have a great weekend. Bye-bye now.
Thank you, everyone.